We can also visualize this in packet tracer. As I said, let's simulate traffic going this way with a source of server A and destination of router 4. Let's do the packet tracer, and traffic is going to be seen by the ASA inbound on the inside interface and routed outbound on the internet interface. So we can go under the SDM, and if we go, let's say, access rules, we can even go to NAT rules, the same thing, and we can fire up from here packet trace. So traffic comes inbound on the inside is going to be, let's say, TCP traffic, or let's say any IP traffic, doesn't matter. It's going to be sourced from server A in here. Destination is going to be router 4.4, and let's say start. So the end result is that packet is allowed, of course, because we've seen that by injecting packets in the network. But if you look in the NAT step, it says in here that it has matched on our object NAT configuration, and it is going to NAT the source of server A into the mapped address of server A. Doing the same thing in packet tracer at a CLI packet tracer of input, packet tracer, input, traffic comes inbound on the inside interface. It's going to be from a source address of server A and destined to router 4. IP protocol doesn't matter, 9, and destination of router 4 detailed. So traffic was allowed, action allow, and if you look in the NAT step, which is in here under phase 2, as you can see, I matched on my object NAT configuration with that traffic flow, which means translate statically translate the source of server A to this address as configured. So that was object NAT of type static. Next, let's do dynamic path. So now what we're going to do is assuming the same thing, that this is my border, my border facing the internet, where router 4 where the direction means that in that direction is the internet. What I want is I want to provide just internet connectivity, let's say with from hosts in this subnet. Vita 92. So as traffic flows through the ASA source from that subnet, I want to do a dynamic path, which means I'm gonna dynamically path all of those IPs from those subnet into a specific IP or multiple IPs, depends what you want to achieve. I'm gonna choose a single IP, and I'm gonna choose to path all traffic into the ASA's internet interface. Because imagine, for example, you have that ASA facing the ISP, and you have a single public IP address which the ISP has leased you, and that IP address is configured on the ASA's outside interface, in my case the internet native interface. So the only way you can provide internet connectivity to those for the inside for the LAN host to the internet is that you have to NAT all traffic into your single public IP address, which because it resides on the ASA's interface, you have to path all traffic into the IP address configured on the ASA interface. So now we're gonna do another. We'll go to NAT rules and we say add. We're gonna add a new object NAT rule. The name is gonna be, let's say, that was VLAN 92. Let's say the name of the object VLAN 92 underscore dynamic path. IPv4, the source IP address is going to be this VLAN 172.16.10/24. So it's going to be 172.16.10/24. And I want to do this time a dynamic path into the ASA's internet interface, into the IP configured on the ASA's internet interface. And likewise advanced, as you can see, the ASA has pre-populated the egress interface to be internet, because for traffic to be netted into the IP address of the internet interface, it means it has to be routed out in that interface, and it makes sense. But as I stated, of course, it depends on the design and what you want to achieve. It's a lot of, let's say, it's mostly a CCNP topic, but ideally, you should always put both the ingress and the egress interfaces specifically. Okay? Okay, and then IP address is an invalid address. Oh, because the problem is that I have defined in here that the object, by default, the object says in the GUI that you're going to put in there a host, not a network. So let's change that to a network. And then we put in there the IP address and then the network mask, which is going to be /24. And say OK and apply. Send. Looking at the CLI now, show run object inline. We see in there the new object which contains that VLAN, and show run NAT, we have a new object NAT statement, which I'm saying that whatever is being matched in that object, if traffic flows inside internet, ingress egress, I'm going to dynamically NAT, I'm going to dynamically do a source NAT for the networks matched in the object. I'm going to NAT those IPs into the ASA's egress interface, which is the internet interface IP. If we say show NAT detail, we see in here that a second rule was added, which says I'm doing, as traffic flows inside internet ingress egress interfaces, I'm going to do a source NAT of type dynamic, and I'm going to NAT all of the sources matched in the object name with that name into the egress interface IP address, which is the same thing which states in here. I'm gonna NAT that source, the origin source, the real source, into the IP address of the ASA on the internet interface. So now if we want to simulate this traffic, now to begin with, because it's path, traffic cannot be initiated both ways. So path doesn't allow traffic to be initiated both this way and this way, because this is not a one-to-one mapping, it's a many-to-one mapping. Because all of those hosts from this VLAN, as traffic is routed by the SA out on the internet, are going to be known as, on the internet, traffic is going to be seen as being sourced from the ASA's interface. So because it's not a one-to-one mapping, it means I cannot have bidirectional traffic to be initiated. Because this is a dynamic NAT, if you say show xlate, we should see nothing in there. We see only the static object NAT configuration from the previous example. Now to simulate NAT, I'm going to, let's say, telnet from router 1, but with the source of this VLAN out to router 4, and traffic should be NATed. Let's go on router 1 and say telnet router 4. with a source of interface gig0192 because I want to match on the NAT statement now. Slash source interface gigabit 0192 Cisco. And if we say who, I should see that router 4 sees me, doesn't see the real address of router 1, but sees the ASA's address from the egress interface of internet 136.1.47.16, which that's ASA's address from the internet interface on gig 00. If we now look on ASA tree and say show xlate, a new entry showed up of type path. So it says that the router does path for TCP because this is a TCP session, and traffic coming from the inside from router 1. This is the real source address. It was NAT as it went outside to the internet into the address of the ASA. So this is the ingress interface. This is the ingress interface. This is the source, the real source address. This is the egress interface, so traffic was routed out on the internet interface. The source was mapped to the IP address of the ASA, mapped source address. And of course, if you say show connection long, you're going to see the same thing, show connection long. We've seen here that traffic destined to router 4, it was sourced from the real address of router 1's IP, and that was NATed into the ASA's interface address in there. And since we're here, because now traffic, this traffic was initiated this way, which means traffic was flowing from the high security level interface to the low security level interface. If you look in the flags in there, the B flag is no longer seen because the traffic was not initiated low security level interface to high security level interface, but was flowing high to low in there. Okay. A basic overview of policy NAT. So now let's assume that what I would want is the following. So as server A sends any traffic out on the internet, the ASA is going to NAT servers A's address of 172.16.10.100 into 136.1.47.100. But let's say that what I want is that if traffic is sourced from server A, 172.16.10.100, and is destined to, let's say, the loop router 4, as traffic flows through the ASA firewall, I would want to NAT, of course I'm going to keep the destination as it is, destination 10.4.4.4, although I could NAT that as well using a twice NAT rule, but I want to NAT the source into something else, policy NAT into, let's say, 136.1.47. Let's say 200. Now before we do this configuration using a twice NAT rule, let's confirm that it doesn't matter if server A initiates traffic currently to router 4's address from the subnet or to the loopback 0 of router 4. Currently, traffic is always NATed per the object static NAT statement into 136.1.47.100. So if you go to server A, and let's telnet to both the VLAN 47 address of router 4 and say who. So traffic is being seen to come from, this is the active, the star means this is the active session I'm looking at. This is my session that I'm being connected, the star in here. And as you can see, traffic seems to be coming from 136.1.47.100. Likewise, if I'm going to telnet to the loopback of router 4, I'm going to get netted into the same address of that 100. Telnet 10444, Cisco, and who. This is the active session, the one with the star, and as you can see, I'm again netted into the same address. But once I'm going to confirm my policy NAT, now when I'm going to turn it to the loopback of router 4, I'm going to get netted to that 200. So let's go on the ASA firewall and say, let's say first of all refresh, and now on NAT rules, I'm going to now say add, and I want to configure a twice NAT rule, which I want you to be inspected before the object NAT statements. Now what we put in here is because twice NAT allows you to do both source and destination NAT at the same time. In the upper portion in there, we're going to put the original packet, source and destination. It also states in here match criteria original packet. And in this section in here, we're going to put the actions. What do you want to translate? Translated packet. And likewise, you can translate both the source and the destination. Now, in the source container, you have an option to choose between, okay, if you want to NAT a source, how do you want to NAT it? Statically or dynamically? If you look in here, you're going to see that you have an option to say the source can be NATed statically or dynamic path. But in that container for the destination, there is no selection of what kind of NAT do you want to perform. It's just you get to choose if you want to do NAT or not. And it makes sense because how can you NAT the destination dynamically? So if you do twice NAT, which means in one rule you can do both source NAT and destination NAT if you want to do that, it makes sense that destination NAT has to always be statically. It doesn't make sense. It's like, I would want to, leave my house and go to dynamically somewhere. It doesn't make sense. An IP packet needs to know the destination stat. It has to always be known, the destination. Both the IP address and the port number is statically defined. That's the socket. So you cannot do dynamic destination NAT configuration wise. Doesn't make sense. But in my case, because I want to do only source NAT, so source interface, again, traffic is going to flow. You look always at the traffic flow. You want to NAT traffic as it flows this way. And you can do both destination and source NAT. In my case, only source NAT. And because traffic is being seen is coming inbound on the inside interface and goes out on the internet interface, then the inside interface is going to be your ingress interface. Internet interface is going to be your egress interface. So source interface is going to be inside or ingress interface. Destination or egress interface is going to be internet. Source address, it is going to be server A, the object. I'm not sure if it's going to let me use this object which makes use of a NAT statement. Let's see if it lets me do that, because that object is also used for object NAT. Destination is going to be loopback of router 4, which means I'm going to add in here a new network object. I'm going to name it router 4 loopback 0. It's type host, which means it's going to be 10444. And add that as a destination in there. So, and then let's finish up the configuration, and then we're going to look at the blocks in here. So I'm going to do a static source NAT. I could do whatever, but I'm going to choose static source NAT, and I'm going to NAT this into. I'm going to add a new object, which let's say I'm going to name it router test server A policy NAT object. And I'm going to put in here the mapped address of server A, which is going to be 136.1.47.200. And say OK. That's going to be the translated address now. And destination address is going to be the same. I don't do destination NAT. OK. So what I'm saying in here to read the configuration now. Let's look at the original traffic, original packet. I'm saying that if traffic comes inbound on the inside interface with a source of server A and gets routed out on the internet interface with a destination of router force loopback 0. If that's the case, then I'm telling the ASA to statically NAT the source. So to statically NAT the source into that 136.1.47.200. But for the destination, I keep it the same because I don't do destination NAT. So as you can see, between the real destination, between those two containers of the original packet and translated packet, on the destination, I keep it as it is. I don't do destination NAT. I do only source NAT, but it's type of policy because I'm telling the ASA to NAT that server A into an address only if destination is the router force loopback 0. Let's say OK and say apply. If you look at the configuration now, show run NAT. So we have now the twice NAT rule, which says as traffic comes on the inside interface, ingress, and gets routed egress on the internet interface, do a static source NAT. NAT the server A into 136.1.47.200, and destination has to be static, but I'm keeping both the real address and the map address to be the same, so I'm not doing destination NAT in there. If you say show NAT detail, as you can see also now, so initially we had only the section 2 populated, which was the auto NAT. Now you also have section 1 populated, which is the manual NAT statements. So as I said in the when we spoke about in the theory part, that first the ASA, when it receives a packet, it's first gonna inspect section 1 manual NAT statements. If traffic matches any of those statements, it's going to NAT the traffic as that NAT statement does. If the traffic doesn't match any of those statements, it's going to then look at section 2 and see if traffic matches any of the object NAT rules. And if it does, it's going to translate it traffic as the object NAT rules tells him. If it doesn't match, then traffic gets routed, assuming it's being allowed by ACLs and security levels, and no NAT happens. Now in the NAT details in there, also as you can see that the source is being NATed because origin, this is the real address of server A, 172.16.10.100, and it gets translated to 136.1.47.200. But this happens only if the destination of the traffic flow is the loopback of router 4. And I'm not doing destination in there. I'm not doing destination NAT. I'm keeping the original destination as it was. But I just added the destination in the NAT statement to be able to do policy NAT. Because what's going to happen now is that when I'm going to send traffic from server A, destined to loopback of router 4, server A is going to get NATed into this address, which is 136.1.47.200 as defined in that object. But as server A sends traffic to anything else, which means to the VLAN 47's address of router 4, for example, then server A, the real address, the source origin, server A, is going to get NATed into 136.1.47.100. So let's confirm that. Let's go now on server A. So let's telnet to 136.1.47.4, which means I should match on the object NAT statement and get NATed into .100. And there we go, that happened. So this is my active line, and router 4 sees traffic coming from 136.1.47.100. But now if I telnet to the loopback of router 4, I should get netted to .200 because I'm going to match now on the twice NAT statement. So now this is my active session, the one with the star, and as you can see, I got netted into .200 because I match on the twice NAT statement. Let's also visualize that from the packet tracer. So packet tracer of input inside TCP from server A, run on source port number destined to V947 address of router 4. I should get netted into .100 and match on the object NAT statement. And there we go, we see that in here. So I'm matching on the object NAT configuration, and I'm netting server A into 136.1.47.100. But if I, as we saw before, when we injected packets, when we telnetted, if we do the same thing, but now destination is going to be loopback of router 4, I'm going to now match on the twice NAT statement and get netted into .200. So face to NAT, I'm now matching on the twice NAT statement, which is this statement. It's a very long statement. And server A address gets netted into .200 now, as expected. Now, of course, NAT is much more complex. This is just a glimpse, a basic touch with the ASA for NAT configuration. But behind the scenes, it's a lot more than that. It's much more complex. It's many things you can do back and forth. And as I said, be careful with the any keyword because you can create chaos in a network, in a production network, and you can even bring the network down because of the proxy R feature.